Now we have discussed three EOQ models for how much to order. So now we're going to look at some ROP models or reorder point models. If the demand is constant, lead time is constant, then your ROP is simply D times L, and that's it. But when the demand is not constant, the first two assumptions that we made for basic EOQ, the demand is not constant, it is variable, and the lead time is not constant, and it is variable, then what do we do? Well, then we have to add a safety stock to D times L, because if we still stick to D times L as our ROP, now since the demand is fluctuating, okay, sometimes the average demand during the lead time will be smaller than expected, so in which case you will still have stock left over when the new order comes in, no problem, because the demand turned out to be less than what we expected. But if the fluctuations are such that the demand is larger than D times L, then you would run out of stock before the new order comes in. So for the moment, if we assume that the demand being larger or smaller or equally likely, then 50% of the time you'll be all right, because your demand is smaller than what we expected, demand is less than D times L, no problem. But 50% of the time the demand will exceed D times L and you'll run out of stock. Now if 50% of the times when the customer order comes in you're not able to fulfill the order, that is pretty bad. You want to be more like 90 to 95% of the times you want to be able to fulfill the order, even more probability than that. You want the stock out probability to be really small, maybe 5% or less, or even 2% or even 1%. So how do we achieve that? To achieve that, we add the safety stock to it. So the question is, how big should the safety stock be? Now there are two factors that will determine how big the safety stock will be. One is the level of fluctuations. If the demand variance is large, okay, it fluctuates a lot, then you will need a larger value for safety stock. So if the standard deviation of demand is large, then you need a larger safety stock to protect against those large fluctuations. Smaller the standard deviation, smaller will be the required safety stock. The second factor is the level of confidence you want. Okay, you want the probability of stock out to be very small. So if you want 95% confidence, or in ROP parlance that would be the service level, you want 95% service level, only 5% stock out probability, then you will need a certain level of safety stock. But if you want 99% service level, only 1% stock out probability, then you need an even higher level of safety stock. So larger the service level, the larger is going to be the required safety stock. So two things. One is the amount of variability, the standard deviation of demand, and the service level that you need. So those are the two things that will determine how big a safety stock we need. So we're going to now look at several scenarios to determine how big the safety stock should be. The first scenario is if the demand follows a discrete probability distribution. So for example, something like this. So the demand during lead time, it can be only one of these. So 30, 40, 50, 60 or 70, and there is corresponding probability for each of those demands. So if ROP is given, our current ROP, that is without, this ROP is without any safety stock. Okay. If you set the ROP as without any safety stock as 50, okay, and then we are also given how many orders we have to place per year, what is the stock out cost, so if we don't meet the demand, what is the stock out cost, and what is the holding cost for each of the items per year. So when you increase the safety stock, so you're going to increase the carrying cost for that amount of safety stock. But when you increase the holding cost, now you're going to have less of stock out, so the stock out cost will go down. The reverse is true. So if you have less of safety stock, your holding cost will be smaller, but your stock out cost will go up because you'll have more stock outs. So what is the trade-off between the two? So that's what we're going to do in this problem. Now how do you come up with the stock out cost? Stock out cost is a function of the two things. One is the immediate lost profit. If you can sell the product, which you're not able to now, you would have made a certain amount of profit. So that profit can be easily calculated, and that is one part of it. And then you have a second part, which is when you have a lot of stock outs, the customer will get annoyed or frustrated and they'll go away never to come back. So the future profits of customers walking away from you forever, okay, that is difficult to estimate. So you have to estimate that as accurately as you can and add that. Maybe you can say, all right, maybe 20% of my customers will never come back. So I'll take the profit margin and then add 20% of that to the profit margin, and that will be my stock out cost. So you have to estimate the second part, which is kind of difficult to estimate, and add the two. Okay. So we're going to look at, so what we need to do is we start from the maximum. So if you set your ROP to 70, then you'll never run out of stock. So what will be the cost under that scenario? Then what if you set up your ROP to 60? So what will be the cost? So holding cost and stock out cost. And then if the ROP without any safety stock is set at 50, then what will be the cost? You don't have to worry about the other two because this is your present ROP without safety stock. So you don't have to worry about 40 and 30 because you'll never consider those numbers. You'll only consider what is the ROP without safety stock, and then you add the safety stocks of the higher demand levels and compute the cost under those circumstances. So going from the maximum amount, additional holding cost and stock out cost. The next level, additional holding cost, stock out cost, and then select the one that is least cost. So we'll now work out